In this module, you will learn about one of the fundamental elements of electric circuits, the resistor. The resistor is a passive electrical component, which owes its name to its current-reducing properties. In common terms, it resists the flow of electric current. Any element of an electric circuit has resistance. For example, the resistance of a piece of wire is proportional to its length, and inversely proportional to the area of its cross-section. As you probably guessed, two elements of identical dimensions, but made from different materials, have different resistances. The property that characterizes resistance of a specific material is called resistivity. Generally, pure metals have the lowest resistivity. The active resisting part of the resistor can be composed of either various metals, or non-metals. Metal resistors are usually composed of a metallic helicoid or simply a metal wire coil. A resistor made of silver wire, which is one of the best electrical conductors, will have a lower resistance than one equal in size made of copper wire. In turn, a resistor made of stainless steel wire, will exhibit a resistance about 40 times higher than a copper wire. Non-metal resistors are typically made of a conducting block element, often graphite or graphite-based material. Since resistors resist the flow of electric current, the energy they consume is converted to heat. For that reason, each resistor has an upper limit of current it can carry without being destroyed, and that parameter is related to both the melting point of the resisting material and its ability to conduct current. In the real world, the resistivity varies with the temperature of the material. In our simulated experiments, we will assume ideal, constant resistivity materials in our electrical elements. In circuit diagrams, a resistor is represented by one of the displayed symbols. In all our modules we will use the International Electrotechnical Commission standard, rectangle symbol. You can see that terminal A is marked with a plus symbol. Terminal B is marked with a minus symbol. The plus indicates that the potential of terminal A is higher than potential B. The potential difference between points A and B is called the voltage drop or commonly, voltage. In electrical circuits, it is usually represented by the character U. The electric current is indicated by the letter I. The electric current always flows from the point of higher potential towards the point of lower potential. If the current represented by the red arrow passes through the resistor, a voltage drop U appears across the resistor. A voltage drop is represented by the blue arrow. You can see that in the resistive element the voltage drop always points in the opposite direction to the current that flows through this element. Ohm's law states that, for a given conductor, the ratio of the difference in potential between its ends is directly proportional to the electric current flowing through that element and is called resistance. You may also say that the voltage drop across the resistive element is directly proportional to its resistance and the electric current flowing through that element. Our technician has just connected a simple DC circuit, so you can study Ohm's law. Let's follow the connections he has made. The voltage supply is the first component of the circuit, and is connected through a switch, to an ammeter that measures the circuit's current. From the ammeter, we have a lead to the resistor, and from the resistor, back to the second terminal of the voltage supply. There is also a voltmeter connected across the terminals of the resistor, so we can measure a voltage drop across the resistor. The essential component of this experiment is the resistor, so named because it resists the flow of the electric current. After checking for any short circuit, you are ready to take some measurements. Turn on the main circuit breaker and check that the output voltage is 0. Close the circuit switch by tapping it. Move the voltage supply slider slowly and collect ammeter readings, voltmeter readings, and voltage supply output readings.